Okay, folks, so this is the first of these lab videos where I just go through the video a little bit, or excuse me, through the lab with you. This is my first recording this semester. It'll be a bit rusty. And so I'll just set you up, kind of showing you what I'm looking for. And then the idea is that you will go off and complete the lab yourself. I'm going to record a second video where what I do is finish off the lab completely, and you can just compare what you've done with what's in the second video. Now, in the second video, I'll probably set up a situation where you can just, if you think your code is right and your output is right, you can just check your output against some different things. Okay, so let's see. So in this first lab, we're just kind of getting you back up to speed with what you've done recently. So this is just going to be on the worksheet. So when I say the worksheet, it just means this thing, not in any VBA or anything like that. So the first thing we're looking here, suppose that we have some physical process modeled by this function of time. Use an Excel worksheet to produce a graph of the function from 0 to 60 and suggest a process. So I think I can do all these questions probably just here. So what I'd like, if I'm to produce a graph, well, maybe I'll do the first one. So this will be exercise, worksheet, exercise 1. Okay. Okay, so personally for me, if I'm plotting something, I like to have column labels. So I'm going to have T here, and I'm going to put theta. If you want, you should be able to put in some kind of a symbol. If you really want, probably unnecessary. Actually, we'll just do it just to show you. Theta, here we go. Okay. Personally, when it's me, I like to make them bold and I like to center them. Okay, so we're going from 0 to 60. Presumably, we'll just go every second. So 0, 1. And then if you just select these two, you should be able to drag it down to 60, something like this. Now, what we're looking for in here is that you implement this. Now, there's only really one thing to look out for, which is how do you do this A to E. Now, the one thing we might say is this isn't 80 by E to the power of minus 0.07t. We have BEMDAS knocking around, which means that you do exponents, that means powers, before multiplication. So you do the exponential first, so it's e to the minus 0.07t times 80. Now, it's kind of difficult for me to help you here without kind of giving it away, but certainly what you're going to want is, I'm going to do a different one, so let's just call this f. So f of x is, say, x squared minus 1, which is not what we're supposed to have here, but just to give you an idea. So you would do equals. This would be, well, maybe it should be t here, excuse me. So you do equals t squared minus 1. That would be for this other function. And then if you want, you can just double click this bottom here, and it'll produce the rest of it. Okay. So, and then if you want to graph it, all you really have to do is just select the two columns like that. And then, is it insert graph? Now there's a choice, you have this one or this one. So basically this is all we actually have, but this is kind of Excel. So this is discrete and this is continuous. Probably most time we'll do the continuous. And if you want me here, maybe I'll do, it's V versus T or something like that. Okay. Now that's not actually what we've been asked to do here, because this isn't the function. So I'm going to delete this. And you're going to have to figure out how to do this thing. So it's obviously going to be similar, equals to 20 plus 80 times. And then how do you do the exponential is the issue, right? So the exponential, if you want to do an exponential on Excel, it's equal to exponential of. So the e to the power function, for maths on VBA is exponential of, and that should be enough for you to complete question 1. Okay, question 2. So what you're doing here, so you want one graph. If you want to plot multiple things in the one graph, so you've only got one x-axis, one y-axis, but multiple functions. So there's only going to be one lot of x's. And I'll go with this. So you're going to have your x's, but you're going to plot w, v, and m. Okay? Your x's are going from 0 to 6. Now you could go on point ones, it doesn't really matter, that's up to you. So you do 0, 1, 2, 3, 4, 5, 6. Then you put in the w, so the w is easy, so it's 12, and it's 12 the whole way down. And then you have to put in the v, put in the m, okay? And then how do you plot it? So I'll just put in, again, a different function that is not the right function, say squaring. So v of x equal to x squared. Looks something like that. And let's say, for argument's sake, m is equal to e to the power exponential of this. Excuse me. So they're not the right functions, because look, here are the two functions, but I just want to show you how you graph all of them. You just select all of them like that, insert, and you get something like that. That's how you can get a graph which plotting multiple functions. And obviously these are incorrect, so you're going to have to fix them. There's a little question here about suggest a process that it might be modeling. So when you produce this plot, have a think about what that might represent, and I'll give some answers in the second video. Similar story here, what will this represent? Okay. The third one. Produce a graph that shows a wave with this kind of properties. Worksheet exercise 3. So you've got to just have a little written work here to get the right form here. So A here is the amplitude, so that would be 10. 3 cycles, probably best to just do trial and error. So we're going to predict, when we're going to plot this, it's going to be a wave. So just change your values of x until you see 3 full waves. 1, 2, 3. That's probably the best way of doing it. You also must find the omega from the period. So this will be 20 is equal to 2 pi omega. That's a little equation just to solve for omega. So we're looking at 20 equal to 2 pi over omega. Just solve that for omega. When you, what you shouldn't do, one of the big things we're going to hear about is kind of rounding error. You shouldn't introduce additional rounding error. So don't use pi is equal to 3.14. Use instead pi. Now, a good question is, why the hell is in Excel do we have to use pi with the brackets? The reason is the pi is given as a function, kind of. It's kind of weird, but it's not quite a function because you don't have to give it an input. So it could be just that there's only one input. But they didn't bother naming it, so they just said there's no input, but the output is pi. So don't use 3.14, use this thing. Okay. So again, you're going to be going with x, y. Your x's are presumably going to start from 0. You might go on 0.1, 0.2, etc. Now, you might know about waves, and if the period is 20, how far do you have to go for 3 full cycles? That's something you might figure out. And then here you do so you're equal to your, again, so the amplitude here is 10, it'll be 10 by sine of omega. You'll have to solve this little equation times x, which is in column A, and then the phi, you can take the phi to be 0. Okay, so that's setting you up for that one, and then obviously plot it. Okay, not too bad. So now we're going to move into VBA. Okay, so in each case, create a command button that when clicked. So you probably may have forgotten some of your VBA. So hopefully this will be a good reminder for you. So we'll call this command buttons, InputBox, and MsgBox. Now I'm rusty, I haven't done VBA in a year myself, so if I make mistakes, I won't feel too bad. Okay, so you're going to want to be on your developer, I recommend starting your code by doing an ActiveX button. So this can be the first one. And you can launch your code like that. Okay. If you want, you can maybe go back and say, oh, what do we want to do here? Properties, is it? Yeah, and rename it. Well, it's caption. So the name is what it's called in VBA. So if you change the name, you'll have to change the VBA code as well. I'm just going to change the caption. This is, it's going to call it exercise 1. Okay. Here we go. So you can go into view code, and this is where you get the name of it. And if you change the name of it, you'd have to change that. Now, I always recommend using option explicit. Now, the point of that is it's going to capture when you have typos in your code. So, for example, suppose you're using DBLX, and by accident you write DBLC. If DBLC is not a variable, and you don't have option explicit, it'll assume to be 0. But if you have option explicit, it'll ask you, oh, what the hell is this DBLC? Okay. So the question here it wants us to do is command button, we've done that, excuse, prompts the user for a number and then displays a message box giving 10 times that number. So what we'll go for is here we want a number that's coming in. So take a number as an input and then produce in a message box 10 times that number. Now, you're going to have to get into using variables soon enough, so we may as well introduce a variable which will be this number. Now here, there's nothing saying this has to be a natural number or anything. So it could be like a real number, and for us, a real number is a double. Okay, so let's define a variable. DBLX as double. So that's how we say that DBLX is a double variable. Basically, a double for us is a real number, so something on the number line, decimal. So take the number as input. So what we want to do is DBLX is equal to InputBox, and an input box is how you give someone give the user a chance to give a number in, and then I think you put the question in here. So give me a number, please. Okay. So that's defining your DBLX, and then to do the output, just do message box, and then you just do say 10 times DBLX, and that should do it. Okay. To run it, I think we can do F5. Give me a number, 4.5. Output is 45, something like that. That's okay. So that one's actually done for us. Okay. So let's do a second one where I shouldn't have done everything there, but anyway. So insert another one. So this will be example 2. Should be able to. Okay, I want to be able to. Thought there's a way of just changing the text. Okay, there maybe you will find it. Caption exercise 2. Okay. So here, what have I done? So the first name, surname, and then okay. So here. Again, you're going to have a situation with an input. So I recommend use variables. And the variables we're using are going to be names, so they're strings. So I'll do the first one for you. So dim str for string. String is letters. For name as string. Now you might need a second one. Okay. So again, you're going to make the program ask user for input. How do you do that? And then there's probably 2 bits of input. Is there 2 bits of input? 2 pieces of input? Question mark. And then produce the output with a message box. Now there's probably one note here. If you want to kind of add, as it were, strings together, to add strings, so like say JP McCarthy, if I want to add them together, what I do is I do say JP and McCarthy. Now the issue with that is the JP and the McCarthy will be kind of joined together. So what you need is an additional space in between, which you can do like that. So I just typed in a space there. Okay, so that's for you to finish off. Then let's see this one, last one, another one. So what's going on here is I'm really doing too much for you, but you have to put in the effort after this. You grappling with the code is where learning is going to happen. Exercise 3. Okay. So now this one. So what do we got? Temperatures in Celsius are related to temperatures in Fahrenheit as follows. Create a command button that prompts an input box to do an input, converts it. Okay, so here you're probably thinking about, I'm certainly thinking about variables. Think about variables. Maybe a variable for F and a variable for C. Now they're both going to be real numbers, so they're going to be maybe dblf and dblc. Okay, so define those variables, then ask the user for input, then maybe calculate from, so it's going to be Fahrenheit, calculate temperature in Celsius, and then produce the output. So that's kind of thinking your way through in advance. Okay. Now we're looking at the ifs and elses. Okay, so I'm going to go on to if and else. I don't know, I don't think I'm going to be providing these files for you. Okay. So in each case, create a command button that when clicked executes the correct code. Now there's some pseudocode here on page 139, which is giving you the basics of it. So this is page 111. So this stuff is here, it's in the manual, it's handy. Get me out of the way there. Okay, so in each case, do a command button. All right, so same story, I would insert using a command button. So this would be example 1. I'm annoyed I can't. Did that work? I don't know. And design mode. Now, into design mode, out of design mode. If you click it, it'll run it. If you're in design mode, it'll bring you into this thing. Okay. Again, we want option explicit. Okay. Prompts the user for a number strictly between 0 and 10. Now, that's certainly going to be a variable. So define variable. There's definitely one variable there. And then ask user for input for initial value of variable. Okay. So if the number is not between 0 and 10, then display a message. Now there's different ways we can code things, and I'm not an expert coder by any means. I'm more of a mathematician. So if there's ways that you can produce the same output, it's slicker, go for it by all means. Okay. So I'm going to kind of go, let me see. So let me use the variable. Let me set up my syntax first. So I might have to cheat, as I said, it's been a long while. Okay, something like this looks pretty good. I'm just going to copy this. No, that's not really, after all, I won't be copying things. But that's just to get me started. So the condition here, let's make all this a comment. So if the number is not between 0 and 10, so there's probably, you've got something called De Morgan's laws, which is about not A and B is not A or not B, and not A or B is not A and not B. But it's kind of up to you to think about it. So the way I would probably say is that if it's less than 0 or bigger than 10, then it's going to be a message box. So the first condition is the variable, which it's just a real number. So x, now you'll call it dblx, but I'm just going to write x. So if x is less than 0 or x is greater than 10, then you want the message box saying what it's supposed to do. Else. So this is if the condition is not true. But I think what we want here, and again, you might just need a little bit of work. I think it's else if is what you want here. Else if, and again, you'll just have to work with it a little bit. I'm not perfect at it, so it might be like written like that. It might be written like that. That's kind of for you to figure out yourself. So else if the next one is between 0 and 5, then it's like this. So if to me between 0 and 5 is you're bigger than 0 and less than 5. So if x is bigger than 0 or equals, bigger than or equals to, I think that works. And x is less than 5, then the other message box. And then I think you have another else if, what's the next one? So then the other possibility, then okay, so then there's the condition 3. It's for you to figure out. And then the message box, whatever it may be. And then you can probably just do an else there because I think there's only going to be one other possibility. So I'm just going to do dot, dot, dot. Okay, that would be how the first one goes. Second one. Oh, excuse me. Okay, we go again. So prompt seizure for a whole number. So you're going to have a variable involved. You're going to have an input situation involved. Then you're going to have an if loop. I'll let you kind of work around that yourself. And similar story. Now there's some little hints in here. On the third one, similar story. Okay, we'll leave that one off now. Now we'll set you up for the do loops. Similar story, insert something, and this will be exercise 1. Again, I recommend option explicit. Okay, what's going on here? Open up new worksheet, done that. Use a VBA to put 50s along the diagonal. Okay, so we'll set you up here a little. I'll probably just do this one with us. Yeah. So what we're going to do is we're going to start in the upper left-hand corner, and so that'll be like cells 1, 1. And then the next one down is cells 2, 2, and then cells 3, 3. And we need something that keeps a count of that. So in terms of variables, need a counter. Now a counter is a whole number, it's an integer. So we're going to do dim int. I'm going to call C for counter as integer. And that's going to be our whole number. Okay, and I think that's all we're going to need in terms of that. Okay, so when we have a variable, we're going to give it initial value. So we're going to call int c equal to 1, and it's 1 because we're going to start up here. I probably need to move this, and this is cells 1, 1, and then this is cells 2, 2, and it's going to move along that diagonal. Actually, I might make these smaller. Yeah. Okay. View code. So that's the initial value. 50. Okay, and we also probably, what we can do is we can use, we could have a variable, like it's going from 1 to 50, that could be a second variable, but we will use the counter as the variable that is not only counting the number of loops you do, but it's also the actual number you throw in, because remember what you actually want to do. You want to put a 1, then a 2, and then a 3, and then a 4, and then a 5. And then keep going up to 50, okay? So this is what we want to do. So we're going to use that counter for that as well. Okay, so how does it go now? So do. Now we can either do while or until. Now we might have to, there's all these one out errors, so will it be while the counter is less than 50 or less than 51, or until it's equal to 51. Now there's two options on the do, right? And then you can put the while at the top of the loop or the bottom, and there'll always be one out. Now there's a very important point to make here. If you are using integers, it is true, or it uses exact arithmetic, as far as I know. Now maybe if you get really, really big numbers, that doesn't happen. Arithmetic. So like you can keep counting up to 50 and it'll be stored as 50. But if you use doubles, that's like decimals, then they are not exactly stored. And what I mean by that is, so you could go 0, 0.1. This is what you think the computer is doing, right? And you might say, do keep doing things until, say this is a variable called x, well, dvlx equals to 1. But the problem is when you add up 0.1s, because it's a double, it's not stored exactly. So when you get to what you think is 1, it's actually like 1.000000002 or 0.999999998. So with doubles, you would never use until equals. Now, rather than saying, oh, if it's integers, you can do until it's equals, and if it's doubles, you do, so here you said instead until it's greater than, something like that. I just recommend don't do until it's equal to. It's probably not a good idea. Okay. So we're going to do, we'll just write do instead. So what we're going to do is, okay, so there's going to be a printing phase and a next value, and that's going to be a common thing. This is actually seeing something that we're going to see the whole time. So through this, it's going to be define variables. That's going to be the first thing you do. Give the variables initial values. Then you do a loop. And in the loop, there you do two things. You print, and then you calculate the next value. That's the basic structure of all of the code in this module, okay? So do, so the print is cells, int C, they should both be big, C, equal to int C. So that's the printing, and then you calculate the next value. So you want to up the int counter by 1, int C is equal to int C plus 1. And then loop until, now if I said int C was bigger than 50, what would happen? So say it's at 49, it'll print this, then it'll go to 50. It won't be bigger than 50 yet. It'll go one more, and then it'll go to 51, and then it'll stop. Okay. Now, if you want to, there's one thing we want to show you. If you want to test your code or find out something that's wrong with it, or just trying to understand your code, what it's doing in the first place, the button for you is F8. So if you go up the top here and press F8, it's going to go through the code line by line. So, okay. So here, see there, I execute this, and that says int C is equal to 1. So do. So this is going to be cells 1, 1 equal to 1. And look over here, it does it. Then this is going to put, at the moment the int counter is 1. This is going to put it up by 1, 2. See that? And then is int counter bigger than 50? No. So it's going to loop. It's going to go back to the start. And now the counter is 2 equal to 2. And then we keep on going like that. And eventually, of course, if I press F8, it kind of finishes the job, and off it goes as far as 50. Okay, but that do line by line, you do F8. And if you hover over the variables, it'll give you the current value. So it's like not running the program all together, but just line by line. It's very useful for us. Okay. I'm going to let you figure out how to do the second one and the third one. We might just look at one thing here. Can we get MsgBox? Does RND actually do anything? Yeah. Okay. So RND will give you a random number. So that's going to be your first lab. Hopefully that video didn't go too long. So what you're going to do now is that can guide you, but you try and complete all those. And then I'm going to you'll know yourself whether you've completed them. If you had trouble with one, you can watch me go through it. And if you still don't understand, you can send me your code and ask me questions, and I'll give you video feedback as I fix your code. Okay, hopefully that went well. All I have to do now is stop recording.